Question 1 then, find this area here. It's just the area under this curve. It's a positive area, so it's the integral from 0 to 1 of the y dx. Integrate that then. X minus x squared over 2, isn't it? It's a definite integral between 0 and 1. Top value, take bottom. Put 1 in, we get 1 minus 1 squared over 2. Bottom value, put 0 in, we still get 0 throughout. So we end up with a half. So next one, this one, it's a positive area again. So it's the integral between 1 and 4 here. So it's between 1 and 4 of the y value, which is 1 over x dx. So let's integrate that then. It's positive, so that's fine. So it's log x between 4 and 1, which is equal to log 4 top value. Take away log 1. Log 1 is 0. So we just end up with log 4 units squared. So that's the second one. The next one is a negative x squared minus 4x between 0 and 4, we're told. So area 3 between 0 and 4. It was a negative area, so we need to put a minus there. X squared minus 4x, wasn't it? Dx, let's integrate this then. X cubed over 3 minus 4x squared over 2, which is just 2x squared between 0 and 4. So I'm going to cancel that, put 2. So that's equal to top value 4 cubed over 3 minus 4 squared is 16, 2 16s is 32. That's 4 cubed, that is. I better write that more clearly. That's the top value. Take away the bottom value, which is 0, because they're both zeros, and that's equal to 64 over 3. It's a minus, of course, so it's a minus. This is 64 over 3. Take away 32, which is 96 over 3. Okay, that's what we've got. Minus 32 over 3, which becomes plus 32 over 3, which is 10 2/3 if we tap it in the calculator. So 10 2/3 units squared. A4 now. Now what's that one? Here's the picture here. It's the difference between the y values. The height is just a positive height. 1 minus 2x minus 1. 1 plus 2x minus 1. 1 plus 2x is the top value. Minus 1 dx, and that's to be worked out between 0 and 2. That's what the picture says. 0 and 2. So that's equal to then, it's just the integral of 2x between 0 and 2, which is 2x raised to the power by 1, x squared, over 2. So the 2's will cancel. And that's between 0 and 2. So we just end up with 2 squared, don't we? Top value, take bottom value, which is 4a5. So look at a5. It's a positive and negative curve, isn't it? So from 0 to 2 it's positive, from minus 2 to 0 it's negative of the x cubed curve. So it's the area of the minus part, minus 2 to 0 of x cubed, plus the positive part from 0 to 2 of x cubed dx. You always go from the lower value to the higher value. That's the way around it works. So that's x to the 4 over 4 between minus 2 and 0, plus x to the 4 over 4 between 0 and 2. Let's work it out then. Top value will be 0, won't it? Minus the bottom value, minus 2 to the 4 is 16 over 4. So that's that one. Plus, and then 2 to the 4 is 16 over 4. Minus 0, is the bottom value when you put 0 in. So 4 plus 4, which is 8 units squared. Last one, this would be the difference between the heights. So the bigger height, take away the lower height, root x minus x, between 0 and this value here is where they equal. So where does root x and this, where does it equal? Here and here. So when does root x equal x? Well, if we square both sides, we get x equals x squared. So we'll have x squared minus x equals 0. Factorize that, x minus 1. So when x is 1, is that value there. And when x is 0, is that value there. So we just did a bit of algebra to see where they intersected, and we found the two solutions for x. We had to square both sides to get x equals x squared. Pulled that as minus x, solved the quadratic, and got the two roots. So the area for number 6 would equal the higher value, which is x to the half, which I'm going to write for the purposes of integration as x to the half, minus the lower value x between 0 and 1, wasn't it? That's it. Raise the power by 1, divide by that number, the 2 swings up here, minus raise the power by 1, divide by that number, between 1 and 0, which equals top value, take bottom, put 1 in, we get 2/3, minus 1/2, put 0 in, we get a 0 in both times. Sixths is 4/6 minus 3/6 then, which is 1/6, and that's the area units squared.